Hello, everyone. Welcome to today's webinar, Building Agentic AI for Financial Documents. I'm Grace Lee, Senior Product Marketing Manager at LandingAI, and I'll be your host today. We are joined by amazing lineup, Andrea Kropp, Machine Learning Engineer at LandingAI, Manish Chop, Principal Solution Architect at AWS, and Noma Orokwafo, Partner Solution Architect at AWS. Today, we have a packed agenda for you to equip with the building blocks to build the financial document solutions. And I'll be highlight on upcoming hackathon event at the end. If you have any questions, please utilize chat and team will monitor and answer them. And if time permit, we will cover them after the presentation. With that, I'll hand mic over to Andrea.
Great. Thank you, Grace. Just a few words about me. I've worn quite a few different hats in my career. I'm entirely self-taught as a data scientist. I'm currently working at LandingAI, helping people with agentic document extraction. I live in the Northwest, and my hobbies are tennis and board games. So I've got about 20 minutes with you. We're going to go through a product overview, take a look at some use cases in the financial services and banking industry. We'll spend most of our time doing some real document examples in the visual playground. I will show some code-based examples and also point you to the documentation and some of the security and support information to learn more. If you're not familiar with LandingAI, we are a pioneer in the enterprise AI space, taking a vision-first approach to a variety of problems. So within this world of document extraction, historically, organizations have approached documents as words that happen to have some layout to them. And we fundamentally take a different approach, approaching it as a computer vision problem and saying this is a picture that happens to have some words in it. And because of that, we've really been able to achieve breakthrough performances in this area of document extraction. We are led by the amazing Dr. Andrew Ng, who serves as our executive chairman. And under his leadership, we've been able to process 1 billion images and documents. So what are we going to talk about today? Talking about agentic document extraction, you'll hear me refer to it as ADE quite frequently, so I'm shortening the name there. And fundamentally, this is an API-based service. The API accepts your PDFs, your PNGs, also your docx and PPTX files, and it's going to return to you Markdown and JSON to faithfully represent that original document. So there's that whole mantra of like garbage in, garbage out. We're looking to be the first step in your process to provide a machine-readable, true representation of that original document, no matter what the original document is. A couple of the things that I'll highlight for today is the ability to handle complex layouts automatically. So there is no layout-specific training required. This is all detected automatically through our agentic process. So this eliminates a huge headache of like document layouts changing over time. We can understand tables and flowcharts and spider graphs and other infographics that are embedded within these documents. And everything is entirely traceable. So you'll see that we first chunk the document into different sections, and then when you query the document and you're trying to pull out a specific piece of information like the date, you will have complete traceability to say that date was found in the upper left corner of page 3 with these bounding box coordinates. And it's allowing people to develop downstream systems that are grounded in the truth of the original document. So where is this useful? These are certainly not the only 2 use cases, but fundamentally, we're doing most of our conversations around field extraction and preparing documents for retrieval augmented generation. I'm going to focus my demo on field extraction, and Noma is going to be showing how to prepare documents for RAG using the AWS tech stack. So within field extraction, we're looking at a lot of different user-supplied documents. So these are some of the types of documents you might encounter in the banking industry. I tend to use mortgages and credit applications quite frequently as examples because they're relatable to everybody who's applied for a credit card or applied for a mortgage. You have to supply pay stubs and bank statements and utility statements as proof of address. And then the bank has to process all of these. So perhaps you've never actually thought about it from the bank's perspective of the diversity of all these documents. And then the second example is rich documents that have complex information embedded within them. So extracting text, paragraphs of text, no problem. But what about when you get into tables that have no particular like grid lines, or you get into flowcharts, or you get into infographics? These are the places where other document extraction services have really struggled and where our vision first, agentic first approach has really shown. A couple of use cases in banking and FS. We do a longer version of this webinar where we go into some more detail. I'll just flash a few of these on screen. So depending on what part of your bank you work in, you may not realize all of the other areas that are also dealing with massive amounts of documents. And most of them do fall into those two types, where we have kind of user-supplied short documents or we have information-dense long documents. So for today's demonstration, we're going to focus on identity verification. This is an important process on both the individual and the corporate side. And it's a place where banks are taking in a lot of these individual documents, pay stubs, W-2s, bank statements, and they're trying to verify your identity. So are you who you say you are based on the documentation that you've provided? This can get really complex across different corporate structures, across different international boundaries. The example we're going to do today is quite simplified, right? We're going to look at some pretty standard US documents. Excuse me. But please know that all of the principles that we're demonstrating here really do extend well to those complex documents. So without further ado, let's jump into today's demo. So we're going to be spending some time in the visual playground. And first, I'm going to show you exactly how to get here. So if you're if you're on the LandingAI website and you come to Product Agentic Document Extraction, definitely take the time to watch this welcome video. But if you click this white button, you'll be asked to create an account either in the US or the EU region. And then within about a minute or two, you'll be into this visual playground experience. And this is where you can take an input document, such as this earnings statement, and simply drag and drop it into the user interface. What's happening right now is that our agentic parsing service is trying to understand the layout of this document. What exactly does it contain? Does it have text? Does it have tables? Does it have signatures? Does it have logos? And in a moment, we'll get back the parse results over here on the right-hand side, both in a markdown format and in JSON. I've found that a lot of people are not familiar with what Markdown is. Markdown is going to look a little bit like Microsoft Word or like a plain text document, but it is actually fully machine readable behind the scenes. Okay, so we've got our chunks. Red is logo, green is text, blue is table. We've got purple over here for margin. So the first step in the agentic process is understanding the chunks within the document. Over here on the right-hand side makes it very easy to kind of check these various chunks. So I can zoom in on that social security number, take a look at it on the right-hand side. So again, we do provide an API service, but this visual playground is really intended for you to verify the quality of the extractions. Within parse, there is the markdown and the JSON output. So this is that machine readable version of the document that is also giving you the bounding box coordinates. So for example, the person's name appears in chunk number 7. You can see the name up here. And this chunk ends in 3334. It appears on page 0 of the document, which is the first page. And it has these particular coordinates. So let's go ahead and ask for the name to actually be extracted and returned as a structured field. So here's where we would transition over to extract. We can add a new field such as name. And here you do want to specify things like, do you want the full name? Do you want just the first name? In the interest of time, I'll just make my variable name more specific, and I will run that schema. So what I'm expecting to get back is Michael D. Bryan, and I'm expecting to get back the chunk reference here ending in 334, which tells us where in the document that information was found. So that's the quick introduction to parse and extract. Typically, when people are using extract, they want to extract more than one field, and you can certainly build up your schema one at a time. You can also start with suggestions, and we will dynamically build a schema based on the information we see in the document. I can run this schema, and I'm going to get a much longer result here, including all of the metadata for where that information was found. And typically what we see users doing is working iteratively in the visual playground to develop a schema that they're happy with, and then they would start applying it to many different documents. So here are my extraction results. So of course, ADP is a large payroll provider, but different earnings statements are going to look different. So you're going to want to develop a schema that will work for all of them. And in the case of KYC, actually, we don't need that much information. So I've prepared a few schemas in advance. I can upload my pay stub schema. And this has just the core details that the bank would typically be using for identity verification. So we're going to have things like the name, the social security number, period end date, and maybe something like the gross pay, like if you're applying for a loan. So we've spent a fair amount of time on this earnings statement. Let me show you just a few others that we ran in advance. So here's a W-2 along with some extraction results. Again, we could pull out socials and first names and what year this is associated with. That was the same example as before. Here we've got a checking statement, right? Got some nice clean tables, and then a longer investment statement. So here you'll see this one is 28 pages long, and we can actually tab through all of the pages. This is the first one where we also see a figure type, and I think most of the figures in here are pie charts. I think we get into some longer tables toward the end. The financial industry is really full of these long tables, and it's really a place where ADE has shown where you have a table that's not like 3x4, but a table that's like 20 by 50, and sometimes it's in like 6-point font. We've really succeeded with extracting those types of tables. So I'm going to drag onto the screen here. Let's just kind of make that a simpler background. I'm going to drag onto the screen kind of what this might look like when you do this programmatically. Right, so imagine that a person has applied for loan A and they've supplied those documents that we just saw. So we're going to be able to convert all of those documents into JSON and Markdown. These are the same files that we saw in the visual playground. We're going to be able to save the extraction results, the specific values that we're looking for from each one. And optionally, we can also save the groundings and the visualizations. So what exactly is this? This is the ability to actually save the chunks overlaid on the original document. Or for the case of something like the Fidelity account statement, being able to actually save all of the individual pieces coming from the separate pages. And this is going to be important when we get into building RAG solutions, where you may have a long document and you may want to surface to the user, say, the pie chart that the answer originally came from. So you saw a couple things there on my file system. Of course, and for those of you who work in code, we've got the original schemas in JSON. And now I lost my folder to bring up the... I was going to show you the extraction results, but now I seem to have clicked away from the folder, so we will skip that for now. So that was the demonstration on field extraction. So typical types of documents that you would encounter in the banking industry.
And Andrea,
Yes.
I do see screen okay and my phone okay, but some has reported LinkedIn Live a little bit blurred on the screen. I don't see anything I can do here, but wonder if you have some other setting that we can try.
I do not. You know, we're we're doing this for the first time. It's a new platform for us. So apologies if it's blurry. I imagine that we'll be able to put out a replay, but I am doing this full screen on my Mac, so I'm
Yeah.
not sure what I could do to
Thank
make
you.
that any better.
Yeah, we are recording this session and we'll be able to share that after the webinar. Thank you.
So I'm going to move over to the second use case, which is preparing documents for RAG. And I have a folder here where I pulled out just a couple different pages that would represent some interior pages of various complex documents that have infographics and bar charts and complex tables and checkboxes and other things. And these documents all deal with the credit card industry. Here's a great one with a flow chart and some equations. So let's go ahead and drag and drop one of these into the visual playground. And I'm actually going to do this one with the flow chart. So we've got a fresh page here, and we'll drop that in. So again, we're saying the second use case for financial documents is preparing them for RAG. So this, is an interior page. It's page 7 of a longer document. It has almost no just plain text on it. It's entirely on table and flowchart. And here's a great example of the type of output that you're going to get from a flowchart. Let's do one more just for kicks. So here we have quite a few equations. And what's interesting about this is you can also see that the main document structure is in 2 columns, but these equations 10 and 11 actually cut across those columns. And so agentic document extraction is able to understand the layout and also understand that these equations are going across that main layout. I did a few others here in advance. It was fun to show some things with colors. Right? So a pretty standard bar chart, but also a less typical way of presenting information, which the agentic document extraction does a really nice job understanding. So I'm going to wrap it here and pass to Manish. I will be available answering comments and available after the webinar as well. Oh, I'm sorry, I did say I was going to cover documentation, so I'm going to take my remaining 2 minutes. Documentation. All of our docs are public at docs.landingAI. If you enter the docs in some other location, you can come in here and choose agentic document extraction. There's a lot of information about getting started. Key thing to note is that there's actually 3 sets of documentation here. So there's how to use the playground, which is really quite self-explanatory, how to use the Python library, and how to use the REST API. So definitely check out the documentation. For support, in addition to the documentation, this is the REST API and the Python library. We also have a Discord community where our developer relations specialist is answering questions. There are also bots that are trained on all of our documentation to help you, and a place to ask a question of a human. And we have a lot of end-to-end workflows. So if you come in here and look at the industry use cases or the workflows, these are all examples that work end-to-end using our API as the starting point to get that accurate representation of the original. And last thing I'll touch on is security, and then I'll pass over to Manish. So this is the page that you'll find in the footer on our website. So this is the security and compliance page. We are HIPAA, GDPR, SOC 2 compliant, so you can learn more about those frameworks. And very importantly, in the financial industry, most customers are requesting an account with zero data retention. What's important about this is that your data is processed in memory and is never stored by our system or our subprocessors. So sensitive documents are used exclusively for the extraction purpose and immediately discarded. So this level of security is often required for financial and healthcare use cases. And you can sign up for a subscription and enable zero data retention on your account directly from our pricing and subscription page. So now I will stop sharing and I will pass the baton. Thank you so much.
Thank you, Andrea, and hello, everyone. Welcome to the second part of this webinar session. I'm Manish Shug, Principal Solutions Architect here at AWS. I'm based in AWS San Francisco office, and I work day in, day out with our startup customers in North America region. In the next few slides, I'll share AWS Generative AI services and Agentic AI services, including Bedrock, Strands agents, and Bedrock AgentCore. So we have a lot of ground to cover. Let's get going. Amazon Bedrock is a flexible, comprehensive way to build and scale generative AI applications, including agents. Amazon Bedrock is a fully managed serverless AWS service that offers a choice of industry-leading foundation models to build generative AI applications. With Amazon Bedrock, you can experiment with a variety of top foundation models, customize them privately with your data using fine-tuning and RAG techniques, and create managed agents that execute complex business tasks all without writing any code. Since Amazon Bedrock is a serverless service, you don't have to manage any underlying infrastructure yourself, and you can securely integrate and deploy generative AI capabilities into your application using AWS services, which you are already familiar with. You can implement safeguards and customize your application requirements in line to the responsible AI policies. And you can also seamlessly connect with your company and organization systems, APIs, and data sources to drive the automation. Our customers use Amazon Bedrock to build generative AI applications and deploy everyday use cases, such as enhancing their customer experiences, boosting the employee productivity, and also to optimize the business processes. All the while, AWS is doing undifferentiated heavy lifting in the back of managing the underlying infrastructure and managing the operational needs for your applications. Amazon Bedrock supports various foundation models from multiple frontline providers. This includes models from AI21 Labs, Anthropic, Cohere, DeepSeek, Meta, Stability AI, Writer, to name a few. We also offer Amazon's best-in-class Nova models. Amazon Nova Amazon Nova set of models includes understanding the models. On the whole horizon of understanding the model all the way to creative content generation. Amazon Nova understanding foundation models come in different sizes, micro, light, and pro. Micro is a text-only model that delivers the lowest latency responses at a very low cost. The light model, though lowest in the cost model, it's a multi-model that is lightning fast for lightweight tasks. An Amazon Nova Pro, highly capable multi-model model, which is the best combination of accuracy, speed, and the cost. On the creative content generation side, Nova offers Canvas, Reel, and Premiere models. Canvas is an image generator model with the high quality images. Reel is a video generator that can produce high quality realistic videos. And then Premier model is our most capable multi-model understanding foundation model for complex reasoning tasks. We also recently launched a couple of other models called Nova Sonic, and yesterday we also launched a Nova multi-model embedding model, which is a state-of-art embedding model for agentic RAG as well as semantic search, combining different data sizes like text, document, and images. While the potential of models are out there, developing an agent or agentic system uh, can face some challenges, and these challenges can be starting from a steep learning curve, lack of flexibility into the system and services, and end-to-end control, as well as limited visibility of the operations going on in the back in a multi-agentic system, and then also the challenges to build and maintain these agents and scale them in production. At AWS, we realized that as agents development demands new tools and different frameworks to help developers build them. We have also seen a lot of momentums around frameworks like Crew.ai, LangGraph, Llama Index. And we know that you want the ability to move easily and more easily to use open frameworks with AWS itself. So, keeping that in mind, introducing Strands Agent. Strands Agents is an open source Python SDK from AWS for building agents and using while you are just using a few lines of code. By open sourcing Strands Agents, AWS aims to provide developers with powerful, flexible tools to build agents in the rapidly evolving agent landscape. It is simple to use and it eliminates the need for complex or agent orchestration by using the capabilities such as state of the art models to plan, chain of thoughts, call tools, and reflect. With the Strands, developers can simply define a prompt and maybe a bunch of tools in code to build an agent and then test it locally and deploy it in the cloud if needed. Like the two strands of the DNA, strands connect two core pieces of the agent together, the model and the tools. Strands agent plans agent's next step, and it executes the tools using the advanced reasoning capability of the model itself. For more complex agent use cases, developers can customize the agent's behavior in the strands itself. For example, if for example, you can specify how tools are selected. Maybe you can even customize how context is managed, and you can choose where session state and memory is stored. You can also build multi-agent applications using Strands. Strands can run anywhere, and it can support any model with reasoning and tool use capabilities, including models provided by Amazon Bedrock, and maybe also third-party models like Anthropic, Meta, Olama, and others. We have built Strands to provide you flexibility and speed and the simplicity of the agent development. You can choose the model of your choice, bring the custom model provider of your choice, and deploy anywhere you want. Strands offers a broad selection of tools, as I said earlier. And last but not the least, Strands also offers seamless integration with AWS, Light LLM, and other services. If you want to learn more about Strands, you can scan these QR codes, and we'll also share some of these links in the Discord channel for you to learn more. Now that we have discussed about building the agents and how Strands can help you building the agents at a scale, the next hurdle to overcome is how do you productionalize these agents and scale in production for the production use for your customers, and how do you deploy in production? Despite all of the open frameworks, including Strands and different protocols, getting agents to production is still too hard. This is because of the dynamic nature and autonomous nature of the agents and the effect it has on how developers build and operate using these agents. First, there is the building and configuring and scaling a runtime and execution environment, and then setting up the system for remembering the past interaction, maybe for the short-term memory where you are doing multi-turn conversations, or long-term learning or long-term memory where you are managing sessions across agents. Next, you need identity and access control for your agents, tools, data sources, and beyond. And then you need fine-grained control to ensure the agents can access only the system and data sources they should, so that there is no leakage of data across agents. You also need a way to discover and interact with custom tools and data sources. And maybe you also need ability to code interpret or maybe go to internet or browse and get the information. You also need ability to use common agentic tools, open source frameworks, and maybe interact with browser capabilities, including telemetry and observability for the interaction, so that you know what's going on in the system. As you can imagine, there are so many moving pieces, and combine all this with any model, any framework, and embracing open source, all you can see a lot of complexity built into this. Introducing AgentCore, Amazon Bedrock AgentCore provides you a modular set of services which you can mix and match together to overcome some of the challenges I was covering on the last slide. So AgentCore consists of 7 modular services. It includes runtime, memory, gateway, browser tool, code interpreter, identity, and observability. AgentCore can work with any custom frameworks, any open source frameworks, including Crew AI, LangGraph, including Strands agent. AgentCore also supports model context protocol and agent to agent protocol. AgentCore is also designed to be model agnostic, as I was explaining earlier, so you can bring in any third party or first party model to AgentCore. And AgentCore offers VPC connectivity, which you are very familiar with while you're working with AWS services, so that you can manage runtime, memory, gateway, and all the other services in a more restrictive and private network environment. So let's dive deep into some of these services. So AgentCore runtime itself is a secure serverless runtime, which is purpose-built for deploying and scaling dynamic AI agents, regardless of the framework, protocol, or model of your choice. Developers can securely and reliably run any type of agents, including multimodal, real-time, and even the long-running agents where the workloads might be running more than 8 hours. This is the longest in the industry possible. Runtime is highly reliable with checkpointing available and recovery capabilities to support graceful recovery as well. It can scale to thousands of agent invocation sessions within few seconds. Runtime is secure by design with built-in identity controls, and you can use this to isolate your sessions, providing dedicated compute environment sessions, and even the memory isolation itself. So as you can imagine, runtime provides all those bells and whistles already built in. Then coming back to AgentCore, also equips you with all the other things, which include something like gateway and memory management. So AgentCore Gateway enables agents to securely access tools, transforming your familiar APIs or maybe your Lambda functions into an agent-compatible tool connecting to your MCP servers. AgentCore Memory simplifies the development of your context-aware agents by eliminating the complex memory infrastructure management, while also providing you full control over what AI agents can remember. It scales automatically because it uses a serverless architecture. It also manages the context across session without manual intervention. AgentCore Browser, as I was explaining earlier, provides AI agents with a fast and fully managed browser experience at runtime that automatically scales without infrastructure overhead. Browser tool provides extensive security and advanced features already built in, like session level isolation and others. And it also provides runtime visibility and complete recorded history of all browser interactions, whether performed by agents or the humans. Last but not the least, AgentCore observability helps developers trace debug, and monitor the agent performance in production. It's available across all AgentCore services. So it offers detailed visualization of each step in agent workflow, enabling developers to inspect the execution path and also audit intermediate outputs and even the debug performance bottlenecks. Rich metadata tagging and filtering, which is possible with this, simplifies the issue investigation, while open telemetry compatible telemetry enables integration with existing monitoring tools such as Dynatrace, Datadog, Logsmith, and Langfuse. You can easily add custom attributes and business metadata to your agent trace, making observability directly relevant to your business outcomes and decision making. So all that is good, but what if you need some pre-built agents and solutions which are already out there? Well, we have a solution for that too. So AWS Marketplace now also includes solutions and expertise from our AWS partners like Anthropic, Salesforce, Deolite, and across other areas like pre-built agents and agent tools. We also offer professional services to help you develop and implement any AI strategy, and both for agent development solutions for building your own agents. So, how do you use marketplace solution with AgentCore? As you can look at the screen, together AgentCore and AWS Marketplace can bring some of all the parts together. Customers can deploy and scale AgentCore native pre-built agents from the third party as well as tools from the marketplace using AgentCore runtime. You just need to write a few lines of code and your agent will connect to ready to integrate solutions. If you want to know more about AgentCore, we are going to share this information on Discord channel as well, but here is the QR code to scan it. With this, I'll hand it over to my colleague Norma. But before I go there, if you want to use AWS services during this hackathon session or the process, please look out for more information on the Discord channel, which will be shared later point in time. Thank you.
Thank you so much, Manish. Hi, everyone. My name is Nomo Korafor. I am a partner solutions architect for AWS, and I work with generative AI startup partners. Those who help, and LandingAI is one of the partners that I support in AWS. If you can see on my screen, okay, as you can see on my screen, I have an architecture here to show you. So where we started with this this architecture is, I thought of one of the problems that we have today, especially for people who work like customers of financial system or industries, like myself, who do not read financial statements. So I was thinking about how can we have something, an agent that could read these financial statements, understand them, understand the charts and the graphs and the numbers, and be able to explain this to a layman. So this resulted to me building this financial market analyst agent. We all know that a good agent starts with the data. A quality agent, what determines a quality agent is how the data, the quality of data that is presented to the agent. And in this case, that is the reason why agentic document extraction by LandingAI is very important for this really complex financial documents. So for this use case, I'm going to be focusing on RAG architecture. So here we start with the data. And for our data, we are going to be looking at credit card banking staff report from Federal Reserve Bank of New York. And we have, first of all, we want to upload that data to either LandingAI SaaS solution. We can run also via API for software developers who are on this call. You can use their SDK or call their API to run an extraction on your document. So please, if you're using the API, just make sure there are two types of API. The one that you can use to run for smaller documents and for larger documents. So you want to run jobs on that as well. So here we have the user uploading this file to LandingAI ADE API, and the next we upload the extracted documents to Amazon S3, which is simple storage service, which is an object storage where you can upload your data securely for your agent to use. So we upload these extracted documents that we've extracted from LandingAI. It could be a JSON or a Markdown. For this use case, we're using JSON. And then the next thing we want to do with these documents is to index the document. In this case, vectorize the data so that your LLMs will be able to use that data in terms of semantic search to understand what it requires for additional context to answer user questions. So in this case, we are using Amazon Bedrock knowledge base to index this document. Within Amazon knowledge base, we are using OpenSearch vector database to index this. And once we index the document, we sync the document. And then there are two ways we can present this knowledge base to the agent. One is either deploying it, making it, exposing it via the AgentCore gateway that Manish has helped us to explain the benefits, and then or we can use Strands agents to add it as one of the tools that the agents can use within its toolbox. So here, I want to call out AWS Lambda function, which is a serverless compute service that you can use to orchestrate this whole pipeline, even to like the Amazon Bedrock knowledge base here as well. So now we've have our data ready. It's in our Amazon Bedrock, knowledge base. We use Titan embeddings to embed this data. We want to now integrate this to our agent. So we are using Strands agent, which is a lightweight open source agent that can help you, integrate or build your agentic solution. So here after building the agent, we deploy on Amazon Bedrock AgentCore runtime. It helps us scale our agents serverlessly, like scale up and down depending on the demand on our agent. Manish talked about the how much thousands it can scale up depending on the requests coming into your agent. And here, with other benefits that come with our Amazon Bedrock AgentCore observability, for you to be able to trace, the output of your agent, make sure that it's giving the right output to your users. And finally, you want to authenticate your users when they're interacting with your agent. So here you are able to use your different providers, authentication providers, whether it's O2 or any other type of provider that you already use today. So in this case, I'm using O2 on top of Amazon Cognito. And here we present whatever application we have to the user and they can ask their questions. So let's get into, I want to share quickly what the data looks like before we look at the code. So here we have the credit card banking staff report. We mentioned that we're looking at data that has a lot of charts and a lot of graphs and numbers. So we've already run this through the ADE API to return our JSON, extracted data. And then let me go to S3. So going to our AWS console, I want to show you like what that looks like in terms of uploading to S3 bucket. So you can do this via SDK. You don't have to do this manually, but I just wanted to show. So this is what Amazon S3 looks like, and then you create like a bucket where you upload, the extracted output from your ADE, right? So after that, you want to go to your Amazon Bedrock, where you want to index these documents. So we go to Amazon Bedrock, go into the search, bar and type in Amazon Bedrock. So here, to go to knowledge bases, you go to knowledge base by the left bar and then create a knowledge base. So I'm not going to create a new one, but I want us to look into what we have for the knowledge base. So when you create a knowledge base, you have a knowledge base ID. This is going to be important for when you want to ingest new documents, or you want to sync your documents if you want to run a pipeline. We also have data source. So here we are using our S3 bucket as our data source. You can also add different other data sources if you have more. And for our embedding model, we are using Titan text embedding to vectorize our data. Okay. Now I want to show a notebook where I did some implementation, and we can just do a test on this. So here we have, first you have to install import all your tools that you need to run this and your configurations. So I already set up the LandingAI API key, which you get from, if you have an account with LandingAI, you get a key, and then you set up your region. I'm running everything on US West 2. Also, you have to specify that S3 bucket that you created, and also the Bedrock data source ID, which is in the knowledge base that I shared earlier. And then you want to specify the model ID. For this use case or this demo, we are using Sonnet 4.5. And finally, the knowledge base ID that I mentioned, I pointed out earlier. So here, after importing this, we want to load the extracted documents that we ran through the Agentic document extraction API. And we use this code here, use the put underscore object function to upload the data to S3 bucket. We specify the bucket name and the key. So to sync to our knowledge base after uploading the data to our S3, you use the stats ingestion job. We'll share all this documentation after this, so you don't have to worry about that. And then to build our agents, since we have our data ready, to build our agents, we import the Strands library. And then we use the decorator Strands tool to define the tools that will be presented to our agent. So in this case, we want to be able to query our knowledge base. So here we put in our retrieve API, just to use that to provide to retrieve, just do some semantic search on our knowledge base. And then we provide the Bedrock knowledge base ID as we already configured earlier, right? So now that we set up the knowledge base, we want to initialize the Strands agent. Now that we've set up our tool, we want to initialize our Strands agent. And to initialize our Strands agent, we use the agent library, the agent class here. So we initialize this and we assign some parameters here. One is the Bedrock model ID, which we configured as Sonnet 4.5. And we are giving this agent a name, which is a financial market analyst. We give it a description of what it does. Now, it is important here to pay attention to the system prompts for how your agent would interact with the user. So this is very flexible. This is where your prompt engineering comes in. You want to make sure that you give very clear information. One, assign a role to your agent and what it does, and then give it step-by-step instruction on how to respond to the user. So in this case, we want the agent to involve the human in the conversation, so human in the loop here. And then we go ahead and also add the tool search. So the tools that we have available that we defined, which is a search knowledge base tool. Because of time, I'm just gonna run through here where we set up a chat loop just to engage the user, to add human in the loop here. And then I'm gonna just go ahead and ask a very complex question. So here, let's look at our document. So I want to ask a question so that our agent can describe what this graph does and what it looks like. So let me just go ahead and type in a question here. So say we want to know the relationship between our FICO scores, interest income, credit losses, and default adjusted credit spreads across the figure that I just shared. So let's go ahead and run this. So the agent will first of all do some thinking. Okay, I think it timed out because of the time it took to run this. So let me just restart. Cool. Give me 1 second to run our agent. Okay. Okay, so I'm gonna ask the same question for it to give me a relationship between okay. So I think that the service timed out. We might have to run over this again, but I will share this notes book to everyone so that you'll be able to run this. But because of our time, I will hand off to I will hand over to Grace. Grace, do we have like 2 minutes so that I can just go over AgentCore?
Yeah, please.
Okay, cool. Thank you. So to go over AgentCore, let's say we've built our agent, we tested our agent is working. So to deploy on AgentCore, what we want to do is to first package our agent, depending on what language you want to use. So because I'm using Python, you package your agent as a Python script. And then if you want to specify any other region you want to use, by default it's going to default to US West 2. And then to deploy your agent, you use AgentCore launch on your runtime. So this will help you build a container using code build, and also create all the necessary AWS resources that you need to deploy your agent on AgentCore runtime. So you don't have to do that manually. And you can provision that includes your ECR, your image, your IAM roles, and also deploy the agent on AgentCore runtime for you, including some observability for you to log. And to test your agent, to use AgentCore invoke, including the prompts for your agent to answer. So with that, I'm going to hand over to Grace. Grace, thank you so much for giving me additional time.
Thank you, Noma. Thank you, Andrea, Manish, and Noma for informative sessions. And if you have any question, please utilize the chat features, and team is monitoring, and we will cover after this short promotions. So I like to highlight upcoming opportunity for builder. And if you are a builder and who love solving real world problems with AI, join the AI Financial Hackathon Championship hosted by LandingAI in partnership with the AWS. And you will build and demo intelligence document solution for financial services with a chance to win 5,000 prizes. So here's how it works. You can register now and start building your project. And the submission due for your project is November 10. So all the information about problem statements and detail will be available on the event page. So do please check out and start building a fun, cool project. And among the submitted project, we will select 10 finalist team to be invited to in-person event where they will demo their project, and then we will select the top winner. Here's a frequently asked questions. So how I get the credits. So as you sign up va.landing.ai, you have access to Agentic document extraction for 1,000 free credits. And for AWS, if you want to also utilize the tools that Noma and Manish shared today, please request on our Discord channel, and we will contact you with the instruction how you can access the free credits for AWS tool. Another frequent asked question is, I cannot attend in person in New York. Can I still participate? I'm not in US resident. Can I still participate? So yes, for both. And we have also online only participant award for the best innovative app. So please do check out and submit your project. And another frequently asked question is, can I participate as a single person? Yes, we encourage everyone to form the team to build the project together and submit the application. But if you are single, you can also participate, and you can also join the Discord to find your teammate to participate together. So we love to see what you are building in the project. With that, let me bring our speaker back to the stage. I know Tim has been actively already monitor chat and answer the questions, but with the time remaining, Andrea, I don't know if you see anything like worth to highlight.
Putting me on the spot. So there have been some questions about, I'm going to read this one out loud. How were the ADE extracts processed before uploading them to the vector store, such as data cleaning, context generation, metadata splitting? So the answer to that is that the JSON is actually so well structured that very little post-processing is required. And you may not believe it until you see it, which is why we try to make it very easy to try. So the JSON that you get back, say you have a 78-page document, you can get that back as one markdown file. You can get that back as 78 individual files, and say that there are an average of 2 chunks. I'm making the math hard on myself. You could also get back like the 900 individual chunks. Typically, you may want to filter out things like margin and logo, right? And then when you load things into your vector store, as Noma showed, you might load only the text, the tables, the figures, right? And you've disregarded some of the logos or the margin pieces. So definitely invite you to explore the output. And if you have questions about like how that output actually gets vectorized, we've actually got a couple other blog posts and demo pieces about that.
All right. I see for AWS team side, Fernand's doing an awesome job sharing all the great informations and answer the questions. So maybe with that, we can wrap up today's webinar. Thank you everyone joining today's webinar, and look forward to see you in the next one. Thank you.
Happy building.